Hello everyone, this is going to be a video about quiz number 1. We had two different versions of the quiz, and what we basically needed was to be able to understand the description and draw the corresponding ER diagram. And what is important is to be able to use the correct notation that we learn in the class, because there are several ways of drawing an ER diagram, and to be able to understand each other we are using the notation we learn in the class. And that notation uses rectangular shapes for entities, diamond shapes for relations, and ellipses for attributes. And we connect attributes to entities with simple plain lines, no arrows there. So some people were trying to draw arrows when they are connecting attributes to entities, no arrows there, and with each attribute it is connected to just one entity. So some people also mistakenly connected the same attribute to two different entities. That is also not possible in this notation. Using relations we can connect entities. So the relation would be the relation would describe how these two entities are related together. So for each entity we would also have some primary keys, let's say pk number 1, and to show that this is a primary key we underline that attribute. So let's say for this one also we have pk2, and if it is the primary key we underline it. For each entity we should have some primary key to be able to reach a unique entry in that entity. For relations as well we could have some attributes to add additional detail to a relation. They would make much more sense when we go to the example, but I said let's first see what we can do and what we can't do. One of the things that we cannot do is to combine two entities with a line. This is not possible. So we always need relations to connect two different entities. And we also know that there is an is-a relation to create hierarchy among our entities. And in this notation, when we draw this triangle, the upper part is the parents, and what we connect through the the area under are the children. So let's connect it with some entities. We have the parents, we have child number 1. In some cases people are just connecting it to one child, but that doesn't make much sense. So if we are creating such is-a relations, then we would need a regular relation there, not an is-a relation. So to is-a relation to make sense, we should have at least two children. So let's say this is child number 2, and we should have some sort of difference between these children. If we are just doing this for the sake of creating a hierarchy, and if we are not doing different things on these children entities, then maybe we do not need the is-a relation in there. Let's say we have in the parent, we could have the name. Let's say it is the primary key. Let's say we have also the age. In this entity, let's say we also keep a phone number. And let's say this child has some other relation to do with some other entity. Then it would make sense to have an is-a there. Otherwise, if we do not doing different things with the children, then it doesn't really make much sense. So let's go through the quiz. So we have pet owners that have unique social security number, name and phone number. So let's first try to find the entities. We have the owners, pet owners. Pets have unique ID, name and a species and a birth date. So pets are another table we have. We also have vaccines that have unique ID, name, trademark, and description. And in here we see that the other descriptive parts are the unique SSN, name, and phone number. They are the attributes of these entities. Unique ID, name, species, and birth date. Unique ID, name, trademark, and description. So about their type, we don't need that much description because we are just drawing the ER diagram right now. And between these entities, I see that we had owners, pet, and vaccines. Owner and pet has some relation, and that relation is named as have. A pet owner may have many pets. So we would go into the details of this later on. Let's just find the names of the relations right now. And also we see that the pet and vaccine has some sort of relation. It can be vaccinated. The vaccine can be done on a pet. So let's start drawing. We have owners. Let's call the name of this entity owner. They have unique SSN. So from the unique part, I understand that this is the primary key of this entity. They have a name and a phone number. I connect them with simple lines. Attributes are in ellipses and the entity is in a rectangular shape. We have pets. So the entity name is pets. They have unique ID. From the unique part, I understand that it is the primary key. If it didn't mention that it was unique, then I would need to somehow create or find some primary key for this entity. So for each entity, we should have a primary key. So they have also name, species. So the cat dog is just an example here. No need to like exactly separate it as species cat and dog. So think of it as a string that keeps the species name. So it can be any different animal. Because some people are trying to create a hierarchy using this kind of examples. If we are giving such examples, it is to show that it is something like that. We could have cats, dogs, and many other examples as well. In the project as well, when we give type examples, some people are trying to create this. So in the quiz, some people try to do this. They made a pet and they did this, and after that, what is the difference between a cat and dog in terms of the ER diagram that we are drawing? It is nothing. They are like assumed to be the same thing. There is no different attributes or a different relation for a cat or a dog. So we don't want such things. So when we give species or type examples, it means that it can be anything, and these are the examples that it can be. And a pet also have a birth date. Also we have vaccines. Oh, we are running out of place, sorry. Let's rearrange it. Dırın. Sorry for that. So we have vaccine. Again, it's our entity, and a vaccine has a unique ID. I know that it is the primary key of this entity. Name, trademark, and description. Name, trademark, and description. And these are the attributes of a vaccine. And when we think about it, it is the name or the brand of the vaccine. It is not just one instance of the vaccine. It is, let's say, the number 1 ID vaccine. It is type of, I don't know any vaccine names, but let's say a flu vaccine. And we have some description about it. It is not just one instance of vaccine. It is the vaccine, let's say, not exactly the type, but it is the vaccine itself. Some people thought that it is just one instance because we do not get that information from this text. And then let's go on to the relations. A pet owner may have many pets, so there is some relation between the pet and owner, and it is to have, or a pet, an owner has a pet, let's say. Owner has pets, and there is some more information about that. A pet owner may have many pets. So on the pet side, we could have many pets matching one owner. But a pet belongs to exactly one customer. So some people created a different entity for the customer, but we are creating this veterinary clinic system, and for this system customers are the pet owners, so we don't need a different entity there. But a pet belongs to exactly one customer, so between owner and pet we have one-to-many relation. For one owner we can have many pets. And when we are drawing this, we need an arrow on the pet side that is directed through owner. People are doing some mistakes with these arrows a lot. When we have some relation, we can have simple lines, bold or not. If it is a one-to-one relation, we would have arrows directed towards the relation. So we would have the entities here, let's say E1 on this side and E2 on this side. Arrows are never towards the entities in our notation. They are always towards the relation. And if we have one-to-many, let's say E1 and E2. If we have one-to-many, we have this arrow. And maybe this example is a good one to show how it works. So there is no problem with many-to-many and one-to-one. We have arrows on the both sides or not. But with one-to-many relations, it could be sometimes confusing to which way arrow is directed to. And with this example, let's think that one owner has many pets, and let's say we have these leashes or ropes connecting the owner to the pet, and think that this arrow looks like many ropes, right? So one owner is connected to many pets. For one-to-many relations, we could have this example, maybe to remember where to put the arrow on. Okay, let's keep it there. We did this one, and with the pet and vaccine, we have another relation. A pet can be vaccinated many times. For each vaccination, date information is also stored. So some people thinking that vaccine is the instance of vaccine, they put the date information into the entity, but for the correct solution, what we need to do is to add an attribute to the relation. We have a relation between pet and vaccine. Let's draw that. Name could be like to like vaccinated, something like that. A pet is vaccinated by a vaccine. And we need to store some date information in the relation. We could store the dates. Whenever this pet gets this vaccine, we also store this date and we add it to this relations table. A pet can be vaccinated many times. So if we have a many-to-many relation, it can be vaccinated many times, and the same vaccine can be done to many pets. Some people understood it as the same instance of vaccine is done to many pets, but we should understand it as the same vaccine type, or let's say the same type of vaccine is done to many pets. We should understand it like this. Let's go to the other question then. For this one, we have a student club database. Let's first find the entities. We have student clubs, we have people, we have activities, and between them we have some relations. Each club must have at least one leader. So we see that we have people and they have different roles in a relation. We have a club has at least one member. So both leader and member are people. Do we need a hierarchy to show that? Not necessarily. These are different roles for the relations. A club member can attend to many activities. So we have 3 relations described to us. Let's find our attributes. Student club has a unique name, so we know that it is the primary key, and a foundation year. A person has an ID. ID is most probably the primary key of that entity. We have name and address. Activity has ID again. If something is an ID, a social security number type of thing, it is a primary key. We have title and description. Let's first draw the entities. So we have a student club. Let's just say club. A club has a unique name. Attribute is the name and it is unique, so I underline it to show that it is a primary key. And a foundation year, let's say F year. It is the attribute of club. So this is just a simple line. We have person, entity. A person has ID. It is the primary key. Name, an address, and we also have activities. We have the entity activity, and an activity has ID, title, and description. We have ID as the primary key. We have title and a description. And let's look at the relations. Each club must have at least one leader, but a member cannot be leader in different clubs. So there is some relation between club and person. Let's first draw that. And the role of this person is leader in this relation. So we can say that this is a has leader relation. If we look at from the club side, the club has a leader. The club has this person as a leader. Each club must have at least one leader. So from that, we could understand that there is some total participation from the club side. If we have a club in this entity table, if we have any entry if we have any club, it should have a leader. And to be able to have a leader, we should participate in this relation. So we make this left side, the club side, a bold line to show that all the entries should participate in this relation. Furthermore, we have this, but a member cannot be a leader in different clubs. So we know that for a club, we can have many leaders, but a person cannot be a leader in more than one club. So if we look at from the club side, what we have is for one club, we can have many persons as leader, but a person should not be able to lead many clubs. So we have a one-to-many relation, and the arrow should be on this side. So if we draw these lines for a club, many can be a leader, but a person cannot lead more than one club. A club has at least one member, and a person can join many clubs. So when we use the roles and entity names interchangeably, we should think about them. We should not confuse them. Some people created entities for persons and also for members and leaders in this quiz question. We should not do that. So we should know that person is our entity, and a person could have different roles in different relations. And in here we have a club has at least one member, so there is a different relation between club and person. We could name it maybe has member. A club has some member. And a club has at least one member. It is again a similar thing with the leader. If we have a club, for that club to have some member, we should have total participation on this side. So we are saying that, if I can draw it correctly, we are saying that each club should participate in this relation, meaning that each club should have some members. So we guarantee that there is at least one member for each club, and a person can join many clubs. So this relation is many to many. Many clubs could have, a club could have many persons as members. A person could be member of many clubs. And we also have another relation between members. So members are people. Between member and activities, we have another relation. Let's draw that. A club member can attend. So what we are looking for is a relation to show that this person has attended this activity. A club member can attend to many activities that clubs organize on specific dates, and it is not written, but the vice versa should also be true. So what does that mean? So for an activity, many people could join, and one person could join to many activities. So it is a many-to-many relation. But we have also some other information that clubs organize on specific dates. So the person is attending to an activity on a specific date. We could add it as an attribute to the relation. We could store the dates information when this person attended this activity. And it is also correct to edit here. So activity could have some date information as well, because think about that, one activity could be on a specific date, and if that person is attending this activity, we know that it is on that date. We don't need to repeat it when each person is attending to that activity. But let's consider that the attributes of the activity is limited with this line. If we think about that, then for this one we could maybe use the date attribute with the attend relation. So it is in the description, both of them are like correct. We could understand both of them, but maybe we could do it like that. Then there are some activities taking longer than 1 day, for example, and when a person is attending to an activity, we also store the date information about when this person attended to this activity. So that is basically it. And we did not have any ternary or aggregate relations in this quiz. We did not also use any is-a relations, but to show them, maybe you might need them in your homeworks or projects. In projects you need them actually. Let's show the notation of it. To create an aggregate relation, let's say we have, let's maybe go through an example. Let's say we have students. Attend an exam, and let's say different teachers are grading these exams, and let's say we have an aggregate relation upon this relation. If we have an aggregate relation, we always use a dashed line rectangle. So in the project, people are trying to come up with like different shapes to get their elements inside. Like we should have like regular rectangles to show the aggregation. So please try to draw it more carefully, I should say, because otherwise it might look too much confusing also for you as well. Let's say we have teachers, and teachers are grading attended exams. So if we show it like that, we are saying that a student should attend an exam. We of course have like student's ID as the primary key. We can have many different attributes for these entities. And if we are drawing a rectangle, we should also cover these attributes of the entity as well. So it would be like that. But not other relations. So the aggregate relation says that grade relation is connected to the attend relation, which is connected to student and exam entities. So we are basically saying this with this dashed line rectangle. Then we don't need to cover other relations of the students within this rectangle. So let's say students also enrolled to a class. Class of course have some ID and other attributes. For teachers and exams as well, we have some IDs, names and other attributes. With this aggregation, we guarantee that for a teacher to grade an instance of an exam, a student should first attend that exam. If we just create this relation, let's say G, this G relation to exam, or let's say grade number 2, the grade number 2 does not assure that this exam would have a student that is attended to. So to make sure that the exam we are grading has some students, corresponding students, we need to have some sort of aggregation with this relation, and this is how we show it. We also have ternary relations. With the ternary relations, we are connecting 3 entities through a relation. let's draw that. We have a relation and we have three entities connected. And this is good for relations that need all three of these entities to exist. On this side, we can have students that attend to exams, and those attended exams might not be graded yet, but they are also in our database. And when a teacher grades them, we add them into another table for this grade relation. On this side, we should have all three entities beforehand to be able to add them into the relation. So this could maybe like this. A student attends an exam, and during that exam there's a proctor that is watching the exam. So this is another teacher. So when a student attends an exam, there should always be a proctor there. So this ternary relation would make sure that all three occur at once. But this one, we could have some entries beforehand. So we have some exams that students are attending, but they might not be graded yet. So they are not immediately graded when we are adding them to our database. We can like grade them later on. And with the is-a relation, I already mentioned we are creating some hierarchy, but that hierarchy should have some difference among the children entities. We can have many other many other children. We can have many other children with some difference among them. We could create more depth with our hierarchy. We can have another is-a if we need to. By the way, with the projects, we never need such complications. So in the projects, try to simplify things. That would make the life easier for you and for us as well. They would have some other attributes. And these are basically what we use for our relations. Okay, I think that's all. Thank you for watching.